All right, we may as well get started. Many of you, I assume, are by now regulars of this virtual seminar on monetary economics series. We are happy to welcome you again for the first seminar of the 2026. And it's a great pleasure to have Gernot Müller, a leader in the field, to present his work. When we started out, the plan was that this would be a seminar series on core monetary economics, and it doesn't get more core monetary economics than that. So we're going to have Gernot, and the plan is that he's going to present for about 45 minutes or so. Please write your questions in the Q&A tab, and if there is anything pressing, I will intervene. But the plan is to have the presentation and then talk to each other for another 15 minutes or maybe a bit more. Gernot, the floor is yours. Thank you.
Thank you, Refet. Thanks for the other organizer. Let me share the screen. So this is joint work with Christian Konrad and Zeno Enders from Heidelberg University. And we are very happy to have the opportunity to present it here. So this is about inflation targeting, or more specifically about inflation forecast targeting. Now, as you're aware, central banks started to do inflation targeting in the early 90s with the Reserve Bank of New Zealand being the first, and then followed by the Riksbank and the Bank of England. And by now, many central banks have adopted inflation target as an official framework. Now, there's a consensus out there that because of lags in the transmission of monetary policy, inflation targeting effectively means inflation forecast targeting. This point has been formalized in an early paper by Svensson, and the idea is very compelling. So you think about monetary policy impacting the economy only with a delay, and therefore it seems reasonable to look at your expected inflation, what you expect inflation to be down the road when you set policy rather than at current inflation. And so the inflation forecast becomes an essential input to policy. To make it be a little bit more concrete, let's think about interest rates as the policy instrument. So you would set these interest rates whenever you see a deviation of the inflation forecast from target at the target horizon, where the target horizon typically would be the medium run, say 2 years. And importantly, you would look through deviations of current inflation from the target to the extent that you consider these transitory. Simply because a measure which you take today would come online only at the point when inflation is back to target anyway, and so there's no point in responding to this. This is well understood, and it's very consequential, as I want to convince you by looking at the episode, a specific episode. I want you to think back to December 21, so 4 years ago, roughly speaking, when inflation in the euro area was running at 5%. So this is year-on-year inflation in the euro area in November 21. So prices have gone up already by 5% relative to the same month in the year before. And what's the ECB doing? Well, it's keeping interest rates at zero and engages still in quantitative easing. And why is that? Well, President Lagarde explains this in the press conference as follows. She says, our new staff projections foresee annual inflation at 3.2% for 2022, and then at 1.8% in 23, and again at 1.8% in 2024. So, and then she says monetary accommodation is therefore still needed, for inflation to stabilize at our 2% inflation target over the medium term. So here you have it. So current inflation running at 5%, and still you accommodate, you provide monetary stimulus to an economy where inflation is running at 5%, because you think that 3 years down the road, inflation is still a little bit below target. Now, is that episode special? Yes and no. To illustrate this, let me show you here this graph which shows inflation, actual inflation in the euro area. That's what you have in red here. And then you have the blue dashed line. The blue dashed line gives you for each year in the fourth quarter the projection for inflation as published by the ECB. And there you see a recurrent pattern which we find quite striking. So you have the horizontal dashed line is 1.7%. That amounts roughly to average inflation in the pre-surge period. So before we had that surge starting in 21, inflation on average hovered around 1.7%. And you see that the forecasts, they go quickly towards this average value of inflation relatively quickly. That is, if you compare it against what actual inflation does. Because you recognize that when the forecast converts back to the mean, actual inflation doesn't do so. Yeah. So there's a striking pattern, and the episode I've been talking about, December 21, is here highlighted in green, where you see how the inflation forecast looks like. So the ECB projections, as the president explained, was that inflation would fall below these 2% in the 2 years going forward. Here you have the same pattern as before, except that then this is followed, and this makes this episode particularly striking, by the surge in inflation, which went then up all the way to 10%, roughly speaking. Of course, we understand what happened more or less. Yeah, so there was shocks hitting the economy. There was the invasion of Ukraine by Russia, and so that's clearly some factors which we understand, unforeseen factors, and I come back to that, which explain this surge. But looking at this picture, I think it's fair to ask, are inflation forecasts any good? Yeah, so that's the question we ask in this paper. And we also ask, if they're not good, why aren't they good? And what are the implications for inflation forecast targeting? We think these are important questions. And we try to tackle them in a very simple way. So we're looking at ECB forecasts for inflation. And we established that these forecasts are unbiased. That's good. And then we put forward a simple notion of information content. And I will be more specific about what that means. It's a very simple concept. And we find that if you look at inflation forecasts at a horizon beyond 3 quarters, there is really no information content in these forecasts. Okay. So intuitively, what this means is that implicit in the forecast, there seems to be the expectation that inflation goes back to target within a year. Okay. Now, is this special to ECB forecast? No. We find similar patterns for other inflation forecasts and for other central banks. So this is a pertinent feature of the data, it seems. Yeah? And I will try to convince you of that. Now, in the last step of the paper, we want to make sense of this, and we analyze these patterns through the lens of the canonical new Keynesian model, where the only twist we add to that model is that we account for transmission lags, because these transmission lags provide the rationale for inflation forecast targeting in the first place. And we calibrate the model to match the evidence, and as we do so, we conclude that transmission lags must be very short. Yeah, why is that? That's the simple idea of our theoretical rationale. So let me explain this up front. So the idea is, if it takes a long time for monetary policy to bring back inflation to the target because of transmission lags, then you should be able to forecast inflation relatively well. We can't forecast inflation relatively well, and hence, it can't take a long time for monetary policy to bring inflation back to target. That's the argument. Okay. Now, this is not on optimal policy, so we don't have a welfare analysis. But if we just, take the ECB mandate at face value, which is, after all, price stability, then we reassess how meeting that mandate depends on the forecast horizon, on the target horizon in your policy. And there we show that inflation is less volatile if the central bank targets current inflation rather than forecasted inflation. Okay. So that's the idea of the paper, of the theoretical rationale. The paper brings together 2 literatures, we believe, which so far have been strikingly disconnected. So there's a literature on The quality of forecast, a rich and large literature. We can't do justice to that here. So we have work on the forecast performance in general for inflation, limits to predictability. Also, central bank, we are not the first paper, of course, to assess central bank forecasts. But what is striking is that this literature on forecasts has been so disconnected from the literature on inflation targeting. Because in the literature on inflation targeting, we have very interesting and important work on what the optimal value is, the numerical value for the inflation target, in the face of the zero lower bound, in the face of product innovation. Very interesting work. We also have interesting work on which inflation measure to target. Should it be core or headline? And then we have work on whether these forecasts should be conditional on a path of interest rates or on a rule of interest rates. Yeah. So, but what's been missing in our reading of the literature is a tighter connection between the quality of the forecast and inflation targeting horizon, which we think is really a very important connection. Okay, and as we do that, we find that probably the transmission lags of monetary policy are shorter than what we thought previously. And here we complement an emerging literature which uses high frequency data to revisit the monetary policy transmission mechanism. And this recent work suggests, just like our paper, that the effects of monetary policy are much quicker felt in the economy than what we previously thought. Okay, so that's the idea. And now let's go straight to the heart of the thing and introduce this concept of information content. It's a very simple concept. It has been around in literature in various forms, but here we try to make this precise. And so the idea is we define the inflation forecast. So that's just pi hat for some horizon H, conditional on the information you have in period T. That's one variable. And the other variable we need for our concept is the average inflation rate in the sample. In our sample, what's kind of nice or intriguing, maybe we can discuss this, is that this is practically equal to the inflation target. Yeah, so in the period prior to the surge, the inflation target was famously defined as close to but below 2%, and there the average is 1.7. Now, when we include the surge period, the inflation average in our sample is 2.1%, so not too different. So this difference doesn't really matter, as I'm going to show. So we have the mean inflation, which is equal to the target for practical purposes, and we have the forecast. And then we define the information content, and the idea is that we benchmark the inflation forecast, which we take from somebody doing the forecasting, against the alternative, which is just to extrapolate the mean. Yeah? Formally, you have the information content here as one, so of a forecast for some horizon H, as 1 minus the mean square error of that forecast relative to the mean square error of just extrapolating the mean. So we would say in our specific case, inflation 8 quarters out would be equal to 1.7 because that's the mean. Now we can rewrite this and then you see how it depends on the variance of inflation as well. Now, why is that an interesting metric? To see this, let's look at the limiting cases. Let's first look at perfect foresight. Let's say you know perfectly the path of inflation. So the mean square, the mean square error of the forecast is 0 if you know exactly the path, so you don't make an error, in which case the information content is 1. Yeah, so that's one limiting case. The other limiting case is that the forecast becomes uninformative. When does this happen? Well, that happens when the mean square error of the forecast is larger than the mean square error from just extrapolating the mean. Yeah? And then the information content can become negative. So why is the sample mean a useful benchmark here? Some people suggested, we should compare this to random walk because that's what we often do when evaluating forecasts. But we think, the mean is a very natural benchmark here in a credible inflation targeting environment. So it's really about, do you do better with your forecast than just saying, well, we will be back on target at some horizon H. Okay, so that's the simple idea. We benchmark the forecast against the mean or the target. All right, so data. we pull these inflation forecasts from the ECB macroeconomic projections database. These are forecasts produced by the Euro system. So let me stress up front. So this is in our baseline, just HICP inflation. It comes at quarterly frequency. Importantly, this is inflation year on year. So we look at the HICP in a given quarter and we compare it to the index, in the same quarter of the previous year. And that's what we run with. Our sample is from 2001. That's when the ECB started publishing this series up until 2024. So how are these forecasts produced? We have 4 forecasting rounds in each year, and in June and September, the entire Euro system is involved within what's called the broad macroeconomic projection exercise. So this means the Euro system means the ECB on the one hand and the national central banks on the other hand. So as inputs, the national central banks get an interest rate path and a path for the oil price, which is baked into market expectations. And that's a given for the national central banks. And they also operate on the premise that the exchange rate remains constant and that fiscal policies are set according to national budget plans. And on top of that, the ECB produces a forecast for the global economy. Now, the national central banks get this input and then they run with this. So they employ all sorts of tools. We don't know, what each central bank is doing, but we hear, they run VRs, they run DSGE models, they use judgment. And then that gets back to the ECB, and then there's an iterative procedure, as it's called, which ensures that the forecasts are consistent. So our take here is, that a lot of effort and brain power goes into this, from all over Europe. So this is aggregating a lot of relevant information. So we would say in good faith, this is the best you can do in terms of producing forecasts. This is not meant to criticize anybody, but rather we think this is a very worthwhile and great exercise. And so these forecasts are then updated in March and December by ECB staff. Now, the forecast horizon of these forecasts is up to Q3, 3 years ahead. So it's very ambitious, in particular in light of the results I'm going to show you. So our focus is just 2 years out. That's sufficient to make our point, but the forecasts even go longer. Okay. So here are some descriptive statistics. This is for the full sample. So in the left column, you see the current inflation and then the forecasts up to for 2 years. You have the mean, that's for the full sample, 2.1%. That's what I told you. The second column gives you the forecast error. And we recognize that these forecast errors are not significantly different from 0. In the third column, you have the p-value for the forecasts. And so they are insignificant. In the next column, you see the standard deviation. And here there's already a noteworthy pattern, because if you go down that column, standard deviation, then you see that these forecasts become less volatile the further out you are with your forecast. While the root mean square error, that's in the next column, increases as the forecast horizon increases. That's also something you would expect from a forecast. In the last column, we have that you read from bottom to top, that gives you the increase in the mean square error, the increase in precision as you reduce the forecast horizon. And here you also notice something striking, and that's a recurrent pattern in the data. If you go from the fourth quarter in terms of horizon to the third quarter, so you're more short term in your forecast, then you see the largest gain in terms of forecast accuracy. These are the descriptive statistics. And now I already show you the main figure of the paper. So that's the information content. Of the ECB inflation projections. And we look at 2 lines here because we do the full sample in red and the blue sample, which is stopping short of the inflation surge. So it stops in the third quarter of 21. And what we measure here against the vertical axis is the information content. And on the horizontal axis, we have the horizon, and we have 8 different horizons. And then you see here that 1 quarter out, there's a lot of information there, because the information content is roughly 0.9. But then the striking pattern in our view is that this information content drops very quickly. So 2 quarters out, you're down to 0.7, 3 quarters out, you're down to 0.4, and then you're at 0 when you're at a 4-quarter horizon. Oops, let me try to get to the chat. Sorry. Okay, I think Refet is moderating the questions, yeah? Sorry, guys. Let me still answer this question since it popped up. So yeah, we do not compute mu recursively, but it's really the average from the sample. So we take one value of mu, which is for the full sample 2.1, and for the pre-search sample it's 1.7. Okay,
Sorry,
great.
I was talking while muted, but I was saying please take this one because it's a clarification.
Okay, good, great. So yeah, you see that at a 4-quarter horizon, the information content is 0, and for the full sample, we even get into negative territory, which, if you remember the definition of the information content, just means you do worse with your forecast than just extrapolating the mean. There you go. Okay, so you will see versions of this figure, but I will try to convince you that this is really a pertinent feature of this inflation forecast, not only of the ECB, but also for other forecasters. But to understand a little bit what's going on, we adopt a classic forecasting framework developed 50 years ago, Minzer-Sanowitz. So the framework is just a regression, basically, of realized inflation on the forecast. Remember, het is our inflation forecast, pi is actual inflation, and then there's a constant and a slope coefficient. Now, this earlier forecasting literature has developed something which is called the optimal linear correction of the forecast. That would be the pi c, where you correct for this constant and for the slope. But of course, if the forecast is optimal, then there's no need for correction, because the optimal forecast, would be a slope with 1. That is what Minzer-Sanowitz called an efficient forecast, and it would be unbiased when the constant is 0. Okay, that's the framework: alpha and beta, constant and slope. And then there's a forecast error that's just realized inflation minus the forecast. Now, within this framework, in a recent paper, Preitung and Knüppel, they develop a simple test. And the idea is very simple but intuitive. So you rewrite the Minzer-Sanowitz regression by recognizing that the constant in the regression can be rewritten as 1 minus beta times mu. This is our mu, the mean in the sample. Yeah? And then you plug that into the regression, and then you get to this equation here, yeah, which just links realized inflation to the forecast and the constant, and we have replaced this constant with this 1 minus beta guy. And this equation has a natural interpretation, because you can now think of the beta as a slider, or as the Minzer-Sanowitz coefficient beta basically determines the optimal combination of mu and the forecast when it comes to accounting for realized inflation. So think of this beta as a slider which shifts weight from the simple mean to the forecast back and forth. And then Preitung Knüppel develop a formal test for uninformativeness of a forecast beyond the horizon age, where the null hypothesis is that the weight on the forecast is just smaller than 1/2, against the alternative hypothesis that the weight is larger than 1/2. Yeah? So that's what informativeness means in their setting. And the nice thing for us is that their null is also equivalent to testing that the mean square error of the forecast is larger than the mean square error of just extrapolating the mean. And we basically build on this notion when we put forward our criterion of the information content. And here we have a formal test for this. We can just take the Minzer-Sanowitz regression and then test this Preitung-Knüppel criterion to see whether forecasts are actually uninformative. And we can go one step further, because once the forecast is shown to be unbiased, we can also test whether the forecast really amounts to simply extrapolating the average value to the mean. So that's a little bit, that's one step further. So in this case, the null would be you really attach 0 weight to the forecast, and you just run with the constant against the alternative that there is some value in the forecast beyond just the constant. Okay. that's the idea. And how does it look like in our sample for the ECB forecast? Well, very clear-cut results. So here you have the numbers for the information content, which I've shown you before in the graph. So here you have the numbers, but this is not a statistical test. But in the middle column, you have the test suggested by Breitung and Knüppel. And here you just test whether this beta H is smaller than a half. And the column gives you the p-values for the null. And so we can reject uninformativeness only in these first three horizons. Yeah, so for horizon 1 quarter out, 2 quarter out, 3 quarter out, we can reject that there's the forecast is uninformative. Yeah, and that's just a statistical test for what you have seen in that graph before. Okay, in the right column, we test the null that the forecast is nothing but, extrapolating the mean, and that we can reject only for the first year. So if you go beyond 1 year, we cannot reject the hypothesis that what's in the forecast is nothing but, saying, okay, we go back to target. Okay. So that's what we have in terms of statistical test. And now we move one step further and try to get a statistical handle on why the information content declines so quickly. And we do that by, in the paper, developing this proposition, which shows that you can decompose the information content into 3 components, which we label fit, bias, and slope. And this decomposition sheds some light on what's going on, we think. Yeah? So what's the fit? The fit is just the R squared in the Minzer-Sanovich regression. So how much does the forecast actually explain in terms of the realized inflation? Yeah, so that's the fit. Then we have the bias, which takes away from the fit in terms of information content then, and that's just here the related to the forecast error. And the last term is the slope, and the slope is related to the beta in the Minzer-Sanovich regression. So if the beta is 1, Minzer-Sanovich efficient, then there is no slope effect. But if we deviate from 1, then we also lose information because of having the slope wrong, so to speak. Yeah. And that decomposition is helpful, we think, because we apply it here to our information content in order to see what drives the decline in the information content. Again, you have the numbers here, and you see inflation content comes down to 0 by age 4. And what is driving this, you also see very clearly, it's not bias, because here we are in very low number throughout. It's not slope, because here we are also good. So what really causes the problem is the lack of fit. Yeah. So we have some fit in the first 3 quarters, but then when we move to 4 quarters out, there's no fit left. So what is fit? This is very easy to illustrate. We do this in these panels, which correlate realized inflation with the projection. In the left panel, you have realized inflation against the 1 quarter ahead projection. And here you see what a nice fit looks like. Yeah? So this is a slope of 1. And so that suggests that the projection explains the realized inflation. Now, you move to the second panel, and here you look at 4 quarter ahead projection, and you see how the fit deteriorates, but there is still a positive association of realized inflation and the forecast. So you go to the 8 quarter projection, and there you see a striking pattern, we think. You see that inflation is all over the place, yeah, but the projection clusters narrowly around the target. Yeah, so you go 2 years out, and what the forecast is almost all on target. This is another way of looking at the graph, which I showed you at the beginning, yeah, and inflation is all over the place. So in this sense, it seems that the forecasts of the ECB are doing poorly. So we ask, is this specific to the ECB? Yeah. And the first check we do in this regard is that we look at professional forecasters, which are surveyed by the ECB at a quarterly frequency. So the information structure is a little bit different. So the ECB asks professional forecasters what they expect inflation to be given inflation in the current month, 12 months out and 24 months out. these are some 60 responses each quarter. We look at the median forecast and we compute the information content for these two horizons. Oops. And you see there is no information content at these horizons, which wouldn't surprise you if they have the results for the ECB in mind. Yeah. So also there is no information, and we do the decomposition FBS, and you see again there's no fit, just like for the ECB. And we cannot reject that at both horizons these forecasts are uninformative in the Brighton-Knüppel sense. We also have some evidence for other central banks, and this is due to a student of my co-authors, Paradice. He did this master thesis and replicated this for other central banks, major inflation targeter, Bank of Canada, Bank of England, ECB, Fed, Reserve Bank of Australia, and Reserve Bank of New Zealand. And this is organized in the same way as our figure. So you have on the vertical axis the information content, and on the horizontal axis you have various forecasting horizons. And you see the same pattern which we have established for the ECB forecast, namely at horizon 4 you more or less cross the zero line and you lose information content which you had before. The Fed is maybe doing a little bit better, so Michael may like this, Michael B. So, but yeah, by and large, the pattern is the same. The sample, I should also say here, varies a little bit depending on data available. So we are looking at early 90s up until 2025. In Paradice, you also have the same scatter plots, which we had, but now for all 6 banks. So here is like the Bank of Canada. Again, so this is a good fit for 1 quarter projections, somewhat deteriorated fit if you go 4 quarters. And then if you go 2 years, there's really this string, I think, striking vertical line, which tells us, okay, forecast cluster narrowly and in realization is all over the place. All right. So again, forecasting performance doesn't look so great according to this metric, but here's the thing. This is all based, for all the results I've shown you, is based on forecasting year-on-year inflation, which you might think is not too hard, at least 1 quarter out or 2 quarters out, because if you forecast year-on-year inflation 1 quarter out, you already know 3/3 of the thing. Yeah, this is all realized. Yeah. So a natural question to ask is, how does performance look like once you turn to quarter-on-quarter inflation? We don't have quarter-on-quarter inflation forecast for the ECB, but we have it for the Fed. Yeah. So in the Green Book, you have a forecast for CPI and PCE inflation. And here we look at the same sample period, which we use for the ECB, except that we don't have the last 5 years due to the publication lag of the Green Book. But I think it doesn't matter. You see clearly what's going on, right? So here you have the information content for the quarter-on-quarter forecast. And then you see that in the 1 quarter out, you see there's much less information now. And then, 2 quarters out, there's nothing left. You're in negative territory. Okay. So this is very robust. And then some people asked us, okay, this is headline inflation. What happens if you look at core, which you might think that core is easier to forecast because it's not so volatile. And that's what we also consider here. So here that's the information content for core inflation. And here, in some sense, the picture is worse. Yeah. So what's going on here? Well, you have to remember what the IC benchmark is. So you are benchmarking your forecast against just predicting the mean. And since core is very stable, that also means that you have a hard time beating that benchmark. All right. So this is our empirical analysis. And I think it seems that really the inflation forecasts are not so great, really. You can just as well predict the sample mean for year-on-year inflation. And you can not reject that forecast adjust the mean, really. So if you're lazy as a forecaster, you just as well use the target. All right. Now, thinking where we started, how does this square with the notion of long transmission lags? Let's say, going back to Sven's on 97, if you think that it takes a long time to bring inflation back to target, then it should be relatively easy to forecast inflation. Yeah. So how do we square that? Well, to try to make an effort at answering this question, we revisit the issue in a structural model. Specifically, we take the basic new Keynesian model and we just add transmission lags. And then we're gonna assess the quality of the inflation target in that framework. Okay, here's the model. So no derivation, so I guess everybody's happy about that because this is straight from your textbook, yeah, chapter 3 Gali, except that we have this red stuff there. So there's the new Keynesian Phillips curve, dynamic IS equation, and then the red stuff is the transmission lag, which we model following some old work by Cristiano and co-authors. At the time, these guys were concerned with making the new Keynesian model consistent with the identification restrictions imposed on recursive VR models. You may be or may not be old enough to remember this, but at the time, the assumption was that within the period, inflation is not responding to monetary policy shocks. And so what Cristiano et al. Did, they just assumed on top of the Calvo restriction that prices are preset and other decisions too are preset. There's another paper doing similar things, Bover and Woodford at the time, early 2000s. And we generalized this notion here. So we assume that certain decisions are predetermined by L periods. This is a somewhat rough way of modeling transmission lags, but it's also very transparent. That's why we like it. And other than that, the model is just from the book. We have cost push shock U, which is perfectly transitory. That's added on to the new Keynesian Phillips curve. And purely transitory shock, the U guy here. And then we have the natural rate shock. The natural rate shock is a catch-all for all the other sources of fluctuations in this economy. And we allow this shock to be following an AR1 process. Now, monetary policy does inflation forecast targeting according to a Taylor rule, where the key ingredient is this. So there's some interest rate smoothing, nothing fancy here, but then we have interest rates adjusted not to current inflation, but to expected inflation, to the inflation forecast, K periods out. So that's our target horizon. So we use K to index the target horizon in the policy rule, as opposed to the forecast horizon H, which may not be necessarily the same thing. What's the forecast? Well, this is a FIRE model, full information rational expectations. So the central bank forecast is just a rational expectation of the K period ahead inflation, nothing fancy going on here. This should illustrate how the lags operate in this model. So here we have drawn impulse responses of inflation to a natural rate shock left and a monetary policy shock right, and we assume 3 lags. So if you look at the right panel, you see that on impact, that's when the shock strikes. Inflation is not responding for 3 periods. It's just hardwired, through that predeterminist assumption, and then from quarter three on, it is more or less responding in the usual way, though there's some interest rate smoothing going on and stuff. So this is how the transmission lags operate in our model. Now, the model is super simple, but we try to be ambitious quantitatively nevertheless in the following sense. So we fix parameters at their conventional values, nothing fancy going on here. So standard parameters, this is the slope of the Phillips curve. And this is here the interest rate rule, standard values. Importantly, we set this K guy, we set the K to 8 because the ECB tells us it targets inflation in the medium run, so 8 quarters out. That's a given. Yeah, we have made a big effort in reading the policy documents, and they don't give us the number 8, but they hint and hint and hint at what the medium run is, and so I think it's fair to assume it's 2 years. Now, then we calibrate the model, or more specifically, 3 parameters which govern the shock processes. So we have the standard deviation of the cost push shock, and we have the standard deviation of the natural rate shock, and as a third parameter, we have the persistence parameter of the natural rate shock. And we set these parameters to target 3 moments in the data. We have the standard deviation of inflation. we have the autocorrelation of inflation. And we target these moments because we want the model to give us empirically plausible inflation dynamics. Yeah? Volatility and persistence of inflation, we do get right by construction, by setting these parameters. And on top of that, we target the information content of the inflation forecast 1 quarter out. This is, again, year-on-year inflation in the model. And then we simulate the models. We run the model several times and generate samples of 80 observations, just like in the data. And this is what we get. So that's the model counterpart to what we saw in the data. So the black stars are the data points. And by construction, we are on target here with that model prediction. So that's the model prediction for the information content of the inflation forecast. Yeah? And the blue line here is computed for L equals 0. So here we have no transmission lags. Yeah. So, but the model in this case gets the information content right, which is targeted. It gets the volatility of inflation right and the persistence of inflation right. These are all targets. We set the shock process accordingly. And now we say, okay, how does this look like if we increase the number of transmission lags, but recalibrate the model so that in each instance we make sure we get a plausible characterization of the inflation process? Okay. This is what we get if we move to 2 lags. You see, if we move to 2 lags, by construction, we are still on target for horizon 1, but with 2 lags, we do better in terms of information content. We do counterfactually better because remember, the black stars are the data. So there's too much information content now if transmission lags are if we have 2 transmission lags, and we can continue this way. You know, this is 6 lags and this is 8 lags. So here's the fundamental insight, at least to us. Yeah. So that once you have 8 lags of transmission, that's the original idea in Svensson, 2 years. Yeah. Then you should be able to forecast inflation. That's what the purple line tells you. There's a high information content in this case. Yeah? Simply because it takes so much time for the economy to digest all sorts of shocks, but also monetary policy actions. Yeah? But it doesn't. Yeah? That's what the data tells us. There's no information content in the forecast, and that suggests, you know, inflation reverts more quickly, yeah, to the target. However, you may wonder, of course, inflation is not always on target. Yeah? So what's going on here? Okay, let me skip this slide here and go straight to the determinants of the information content. So shocks versus persistence. Let's think of impulse response to a natural rate shock. Yeah. So even without transmission lags, monetary policy takes more than 3 quarters to bring inflation back to target because the autocorrelation coefficient of that shock is 0.6. That's what we get through the calibration. So there's some persistence in the model, but still no information content at all if you go beyond 3-quarter horizon. So what's going on? Well, you need to remember that an impulse response is a counterfactual. It's a counterfactual outcome, yeah, which you get when no shock hits except for the shock which you study in period T. But actual transition, you know, sees, of course, a lot of shocks. You know, inflation is constantly exposed to new unforeseeable shocks. That's, you know, Putin invades Ukraine. Nobody could have foreseen that. Well, nobody, you know, within the central bank community, I guess it's fair to say. So that's a shock. We haven't seen that. Yeah. So in this sense, it's important to remember that the information content benchmarks the forecast against the forecast that inflation meets the sample average. And that's a hard to beat benchmark when inflation is subject to unforeseeable shocks. We try to illustrate this here. So, you know, this is what goes on in the model. In red, you have your standard impulse response to a natural rate shock. You know, it's persistent 0.6 and it gradually reverts back to steady state. And it would be, you know, not yet at 0 4 quarters out. Yeah. But then we repeatedly simulate the model and draw from the shock distribution, and then we compute pointwise the probability bands of where inflation is going forward. And then you see it's a wide range simply because at each point in time, new shocks come in. And so you may, you know, absent any shocks, you could forecast the red line. But since these shocks come in all the time on top of that, yeah, then it's really hard to forecast this, and then you do better by simply saying, okay, on average we are back to the mean. And this picture is computed without transmission lags. Yeah. So if you now bring in transmission lags, so because this is our preferred specification, remember the model without transmission lag does the best job in explaining the data. We can look at what happens with transmission lags. Let's say 3 lags of transmission. And in such a world, you know, forecasting inflation is easier. You see what's going on because then now inflation is longer away, given the shock in period 0 is longer away from steady state, yeah, because the transmission works more slowly and monetary policy has a harder time of bringing inflation back. In such a world, you should do better in forecasting inflation. That's precisely what the figures before should have meant to convince you of. All right, what are the implications for policy? So let me be brief here in the interest of time. We think that monetary policy transmits much faster than what this earlier VER literature suggests. I want to be explicit here because in the past, somehow people found it hard to square these results with that early literature. Our answer is, well, the early literature is not up to speed yet. Yeah, and the transmission is faster. This is how we interpret this evidence. So what does follow for policy? We don't do full-fledged welfare. We just say, okay, the ECB mandate is price stability. So we can simply ask how changing the target horizon for monetary policy matters for price stability. This is what we do in this graph, the last graph I want to show you. Here we look at the standard deviation of inflation against the target horizon K. This is now not the forecast horizon, but the target horizon, the thing which monetary policy targets in its Taylor rule. And we do this volatility of inflation for alternative transmission lags. So let's look at the green model, which is not preferred by the data, but here we have 3 lags of transmission. And here you get this result that the volatility of inflation is lowest if you target inflation 3 quarters out. We like this result because it confirms the original idea in Svensson, yeah? And I guess it also summarizes the common sense in central banking that you say, okay, if my actions take 3 quarters to impact the economy, then I should look 3 quarters out. The problem with that consensus is that or with this common sense is that it's based on a model with relatively long transmission lags. We think transmission is faster, and that's the blue model here. The blue model has no transmission lags. In this case, you would target contemporaneous inflation, and in this way, you would minimize the volatility of inflation and ensure price stability. All right, I think that's what I wanted to say. Thank you.
Excellent. There are a bunch of questions in the Q&A, but I'll begin with mine. So first, thank you. And this is exactly in the spirit of this seminar series and really interesting. Now, there's a question of, okay, so 2 things. One is, you showed that the inflation forecasts have converged to the target. I see that as a very good thing. So in, way back when, in a sample that kind of ended when yours began, Rochelle and I had shown that the Green Book forecast is terrible. And the forecast using the Smith-Walters model actually beats the crap out of it in terms of forecast efficiency. But the mean beats the crap out of both of those. And essentially what happens is, electrical engineers understand this well. This is a system under control, right? If you're doing proper inflation targeting, inflation deviations from the target shouldn't be forecastable. So essentially what you end up with is the forecast variance turns into forecast error variance. And the Green Book people try too hard. They think that they are able to forecast something that is effectively unforecastable, right? So you're telling me that they are no longer doing that, and that's very good, right? There is a, I would say, interesting question on whose forecast exactly we're looking at, right? And when you're looking at these inflation forecasts, it makes a lot of sense to look at the interest rate forecast as well. This used to be a huge issue for the Fed, right? 20-some years ago, the rule, since the staff is forbidden from giving policy advice, was that the forecast is, what was this? It's contingent on this is the phrase, a helpful conditioning path for interest rates. which essentially meant, first do something of a reasonable forecast and then find the flattest interest rate path that's not grossly inconsistent with it. They've moved away from that now. But you want to think about forecasts of people like you and me, outsiders, where when we're forecasting inflation, we're essentially forecasting, inflation and the central bank behavior jointly. And then the forecast of the staff, who really cannot forecast inflation away from the target at any reasonable lag, because they'll be saying, we think you're going to screw policy up. You're not allowed to say that. And then there is the forecast of the policymakers themselves, which we rarely see actually. And if you have somewhere in the US, you actually have the dot plot. That's actually an interesting thing to look at because it's different from the green book, right? And you might be able to get some mileage out of that. So this wasn't a question, but a comment, but hopefully a useful one. Now I turn to Michael.
Thank you.
Yeah, Gernot, great stuff. Totally buy that inflation is hard to forecast. And really helpful evidence on that. I guess I'm worried about the drawing such a strong conclusion that therefore monetary transmission lags have to be short. And the reason is that I think there are also a lot of other reasons that inflation is hard to forecast. Uncertainty about the state of the economy, uncertainty about the structure of the economy, uncertainty about expectations and expectations formations. We wrote this up in a little taxonomy of different types of uncertainty with co-authors from the board, but so these are not in the model, these other shocks, these other sources of uncertainty. So I wonder how robust that implication that there need to be short transmissions would be to accounting for these other types of uncertainties. And thanks again for a great presentation.
Okay, I respond directly. Yeah, so this is a very important point. I agree. And our model is a bit stylized and it may look benign to warrant such strong conclusions. And I guess we have more work to do. But still, I think the gist of this problem you allude to is still in the model in the sense that we do have transitory shocks, yeah, which make inflation hard to forecast. These are our cost push shocks. You could make this richer and introduce some additional information frictions and so forth. And potentially the list is endless, I agree. But still, the fundamental problem is that it's in the model, inflation is hard to forecast for two reasons. Yeah. Because transmission lags are short and because there is this noise coming in all the time in the form of cost push shocks. Yeah. So I think the fundamental tension is there. And so we adopted for now the most parsimonious specification, which, accounts for noise, which makes forecasting hard. Yeah. And it accounts at the same time for the key features of inflation in terms of volatility and persistence. But yeah, so it remains to be seen whether this is robust to bring in more information frictions broadly understood. Thank you.
All right, and then we turn to Michael.
Yeah, that was great. So I'm going to partly do Refet's job for him because there's a question that's in the Q&A that I also had, and I think it relates exactly to what you said to Michael Barr. But I have 3 points I want to ask broadly. The first is a really naive one from someone who hasn't done anything in the VAR, VEC-M literature for quite a long time. And this question came up immediately at the start, and you sort of addressed it very explicitly at the end. Why don't we see shorter transmission in VAR, local projection, and all of these studies? I know we do see it. One of my co-authors, Stephen, is one of the co-authors of that sort of short transmission paper. So I understand that literature. But is there something easy you can tell me for why that literature, the VAR traditional literature, is missing this? The second one is directly related to what you just said there. I was trying to think about this. The question in the comments is one that I had, which is, what about, endogenous expectations in the model? They're super powerful. In practice, they may not be. And I thought, and I wouldn't mind your reaction to this, like one thing that could be going on is that monetary policy has gotten better. So it may have been when Svensson was thinking about this stuff with his eyes on the 80s and the 70s, that transmission did take a long time because expectations were very adaptive or didn't adjust. Whereas now, and you sort of see it with your professional forecasters' results, they sort of do the same thing. Inflation, their ability to forecast drops because they have the same long transmission in mind, but they seem to believe monetary policy, I think. So I was going to say, like, you could actually answer Michael's question that yes, with some of these added things like in endogenous inflation expectations, etc., you could actually get that the transmission lags would disappear. And I wondered if you've thought about that. And then the last one is, one other thing that I thought about was, what if monetary policy is I'm going the other way now. I'm very schizophrenic in these questions. What if monetary policy, like the lags are still long, but monetary policy is just not as important relative to the other things that drive macro fluctuations like shocks. So if you drive the relative shock volatility through the roof, don't you get this same effect? Even though the central bank thinks it will get it back, it thinks it will get it back on average, but by the time you look at the sort of 8 quarter ahead forecast, their best guess is the forecast, but they never get that right because there's all this extra volatility. Did you consider that model? I'm not sure that's a great message for central banks of the world either, because it says that, actually their influence relative to our standard model is much less than we thought, but does it generate the same charts? But great stuff, really enjoyed.
Okay, great. Yeah, so this is very stimulating. Yeah, so two alternative extremes. So I like the monetary policy getting better. I would find this more plausible than really monetary policy being completely powerless. And my intuition here is simply that if you have so much noise and that explains the low information, then I think our benchmark, which is the target after all, wouldn't do so well either, right? I mean, if you had all these shocks hitting the economy constantly, why would we hover around the target? So I think there is some credit to monetary policy in anchoring the economy near its target, So, but that said, I also would side with your first conjecture that monetary policy has gotten better, and maybe the idea of modeling this through endogenous expectation formation and then endogenizing the transmission lags. I think this is very intriguing. But here I wanted to share one piece of evidence, which we computed for the Fed. So that supports this notion that monetary policy has gotten better. I mean, because we can do for the Green Book the information content. This is now for GDP deflator inflation, but same idea as before. We do this for two samples pre-1980s, the wild 60s and 70s, pre-Great Moderation period. There the forecast is only for 2 or 3 quarters out. Yeah, that's the blue line, pre-1980s. But still, you clearly see this shift in the information content. So when monetary policy did poorly in terms of stabilizing inflation, then the information content was higher. So in that sense, yes, absolutely. This notion that monetary policy got better in stabilizing the economy, and that's why inflation is so hard to forecast, it seems very plausible.
That would also be the case if you just said an AR1 on inflation.
Okay, then we would also see it. Yeah, the persistence as such. A direct test, so to speak. Yeah, exactly.
Okay. So Patrick Honohan in Q&A has were you done with your response to Michael?
Yeah, I think so.
Okay. So Patrick Honohan has a question on whether you can use the 4 quarter ahead forecast of the ECB to tease out the 1 quarter ahead one.
Yeah, I think in principle that's possible. So we haven't done that yet because it involves a few steps which we haven't thought through. But yeah, if you insist, we should be able to do it. Yeah, thanks for the suggestion. Yeah.
Okay. And then there's a question about what if the Minister Zarnov's assumption that the aim is to get inflation right on average is violated, so that the central bank is more worried about deviations on one side than the other.
Yeah, so I think that's also an interesting aspect. I mean, in some sense, you could say this rationalizes our results. I mean, our information content measure makes no assumption as to the symmetry of your loss function, right? So it's just evaluating forecasts based on the mean square error, and that's it. Yeah, we don't take a normative stance here. I'm not sure whether an asymmetric objective on the central bank could rationalize why the forecast why the information content is deteriorating so strongly. I don't see why you should then be worse in forecasting inflation. So yeah, but okay, maybe I should write it. We should really write it down and see what comes out of that. Yeah. So yeah, it's maybe not fully convincing answer. So we have to think through it. Yeah.
Very good. All right, so I'm going to wind it down. There are a few more questions in Q&A, and we're going to email those to you.
Okay.
But let me first thank you again for an excellent presentation. It's wonderful to have all these people here, seminar after seminar, and that's because every seminar is great and it whets the appetite for the next one. And on that note, the next one is going to be Adriano Claire's seminar on February 5th, and hope to see you all here again. Thank you so much.
Thank you.
Thanks, Gernot.
Thanks.